All right, guys, I'm sorry the video is kind of sideways, and I'm sorry it's taken so long. I have a daughter and a wife and a whole lot going on, so it's hard for me to keep up with everything at all times. But here's number 47. This should help you with the last, 5 problems. So this should help you with the last 5 problems. We're gonna they're weird. It's the ones with all the fractions inside of fractions. So the problem is limit as x is approaching 0, and then the equation is 1. Here, let me just do it like this. This will make it way easier to understand and see. So we're going to do 1 over x plus 3 minus 1 over 3, or 1/3, and all of that is over x. Now, if you plug 0 in here, you're screwed automatically. You know that, because a 0 in the denominator is no good, and you won't be able to get an answer. So this is where the sidebar comes in. So again, we don't need to carry the limit here over to here, because this is just your basic math. This is just how you're figuring out the new equation to plug that limit to. So we're just going to take 1 over x plus 3 minus 1 over 3, or 1/3, all over x. So the first thing we need to do is we need to make these two fractions come together, right? I mean, that's just a lot of math. So we're going to bring those together and make it one equation over x, or one fraction over x first. So the easiest way to do that is to multiply and to get like terms on the denominator so that you can add and subtract them. So the only way you're going to be able to do that is to multiply. So in this case, we know we need a 3 on this side because there's a 3 on this side. So to get a 3 on this side, we're going to multiply by 3 over 3, because that's equal to 1. You can always multiply by 1, because 1 over x plus 3 times 3 over 3 is 1 over x plus 3. It does not change this. It doesn't change the value of it, let's just say, okay? So now on the 1/3 side, you need to get an x plus 3 over there. So how are you going to do that? Well, you multiply that side. Here, I'll do that too so you can see that. So that's one side. You've got your subtraction sign in the middle, so you're still subtracting. And you're going to multiply this 1/3 by x plus 3 over x plus 3. And that's all one side. So just remember to understand that. This side is 1. This side is 1. Okay. So now what you get when you do that is you get three minus, because 3 times 1 is 3, right? And then you got to multiply 1 by x plus 3, and you've got that minus sign in there. So you're going to do 3 minus x plus 3. And that's all one thing. Like, that's all one. All right here. That's how you combine that. That's how it combines out. Once you do the multiplication, we still have not used that subtraction there. That carried up here. See? And then we're going to do all over. And then we've got 3x plus 3. It's just 3x plus 3. Okay. So now you've got all that. And remember, we're still all over x. All of that is over x. Now, the next thing you need to do is you need to get rid of either this, or you need to break that fraction down. So the first thing you need to do to get to that point is you need to combine all of this up. So that's equal to 3 minus x plus 3 all over 3 times x plus 3 all over x. That's what that's equal to. Now you can break that down even further and make it way easier too. And you kind of have to. So 3, these 3's cancel because that's a negative 3. So we've got negative x over 3 times x plus 3 all over x. So first of all, y'all need to, no, I'll get there in a second. So I'm just going to bring that down here so that you can see it. So no equals, because we didn't change anything. So we've got a negative x over 3 times x plus 3 all over x. So now, here's something that is very important to remember. This x down here is also equal to x equals x over 1. Always, every time. Because anything divided by 1 is itself. So x over 1 is x, y over 1 is y, z over 1 is z, 100 over 1 is 100. Like that's the math. So anything over 1 is x. So we can make that x over 1 to make it easier, which means we can multiply by, it's called the reciprocal, 1 over x. That'll get rid of that x. See? So when you do that, you multiply it all out, you carry that negative sign to there, and then over to the next one. So you're going to have negative 1 over 3 times x plus 3. This is also equal to g of x. So if you remember on Theorem 9, from this sheet that he gave us, if f of x equals g of x for all open intervals containing c except possibly at c, then the limit here, the same limit for f of x is equal to the same limit for g of x. So you create an equality situation. So that is your g of x. That is the equation you need to plug the information into. So, but you need to also put the qualifier on there as long as x does not equal 0. So you could just go here and say x does not equal 0, or you could just write x does not equal 0. You know, it doesn't matter. I mean, it doesn't. So now we're going to come back over here to the actual problem where we're going to, this is the work that's going to be graded on this side. So we're going to do limit of x as it is approaching 0. And we're going to bring this equation over g of x, because remember Theorem 9 says that g of x is equal to f of x. So this is f of x. So now we're down here, we're going to do g of x. We're going to keep that same limit. So, and we'll label this one f of x. And this one can be g of x. So limit is x equals 0 of negative 1 over 3 times x plus 3. That's a much easier thing to deal with than that. And this one, it won't give you a 0 in the denominator. Plug 0 in. 3 times 0 plus 3. 3 times 3 is 9. So this is also equal to negative 1 over 9, which is the correct answer. And that's how you do that. I hope this helped. If it didn't, please send me a message in the GroupMe and let me know how I can help you, and let me know where I lost you. Thanks.